Hello everyone. So in last video we had started our discussion with respect to push down automata. We had picked that the design of push down automata consists once again extended version of finite automata. In finite automata we had input tape and functioning to perform from that input tape. The restriction was that we do not have memory in this. We had added memory here in terms of stack, and this becomes PDA. Now let's pick that how PDA works. So I have taken one example here which I had picked in our previous lecture, and language L is equal to a to the power n b to the power. I have taken one string triple A triple B, and I want to process this string in my PDA. So let's insert this A, B, B, B. This is blank. Here also suppose I have blank. Now what I want to do, I want to process and I want to check that whether number of A's are equal to number of B's or not. So can we perform this particular analysis by using this small structure? So let's pick that once I'll get A, what I'll do, I'll insert this A into my stack. So once first A I encounter, I have inserted this into my stack A, and then I moved my pointer to the next one because I had processed it. Now whenever I'll get A, what I'll do, I'll repeat the same process and insert this A into my stack. Similarly, I got A, I have inserted this A into my stack, and my pointer is moving towards upper side. It's moving upper side and top of the stack. Now whenever I'll encounter B, suppose I got B, what I'll do, for every B I'll pop one A. For every B. So what I'll do, for this B I'll pop this A, and since it got processed, for this B I'll pop this A, for this B I'll pop this A. After completion of a string, if nothing left, and at the same time if I'm getting empty stack, empty input. If input tape is empty after processing, and at the same time if stack is empty, then I can say that number of A's are equal to number of B's. Hence, as you can see, by simply adding this particular stack, I can easily process this thing. Now in other way, let's see the same thing. What I have done actually, I got number of A's, n number of A's, and I got n number of B's. What I'll do, I'll stack all the A's into my stack, or I'll push all the A's into my stack, and whenever I'll get B, I'll pop for each and every B, I'll pop one A. So if I have n number of A's, then definitely for n number of B's, I'll pop all the A's. Hence, this will become 0. So that's the whole point. Even suppose I want to prove for any language which is having number of A's always greater than number of B's, again what we require comparative analysis, because we want to prove that number of A's are always greater than number of B's. So whenever any comparative analysis get involved, what we'll do, we'll identify that this language does not belongs to regular. It can be from context free. However, please be sure it's not necessary that all the comparative analysis can be performed by context free languages or can be performed by PDA. For multiple memory operations, you cannot use straight away PDA. So there are certain restrictions in PDA also. PDA is only used for simple memory questions like a to the power n, b to the power n. So now the thing is that we have explored that how PDA works. Now what is mathematical definition of PDA? So let's try to focus on definition of PDA. Now the thing is, I hope that you already aware of definition of finite automata. Now what was the definition of finite automata? Finite automata consist 5 tuples. What are 5 tuples? Finite automata have 5 tuples: set of states, set of inputs, then initial state, set of final state, and we have transition function. So finite automata have 5 tuples. Now if you can relate with this particular thing, without memory, this simple particular machine is having 5 tuples. Those are set of states, set of inputs, initial state, set of final state, and transition functions. Now once I'll talk about PDA, just focus on this thing. What I have done actually, I have added one stack here. Have I removed anything from here? No. So what I can do, I can straight away copy all 5 tuples. Now definitely I got here certain new thing, and what I have used here, I have used certain insertion in stack and deletion in stack. Means I am working on the symbols which I have incorporated in my stack. So that will be my next tuple, that is stack symbol. And since I require to insert certain elements, so I need to know that what is base of my stack, from where my stack got started. Hence I require the bottom of stack, which I am saying that is empty stack. So I have added 2 additional tuples in it, and this becomes definition of my PDA, that PDA consists 7 tuples. Now what are those tuples? Set of states, set of inputs, initial state, set of final state, transition function, stack symbol, and empty stack. Now definitely our transition function definition will also get changed. So what will be the definition of it? Earlier the definition of transition function for finite automata was that by taking certain state and corresponding input, I'll move to the next state. Now let's see again what we have processed here. What we have done, that definitely there will be certain state. From that state, I'll check the input and I am going to check my stack. What I have done at the start, that if I got A and whatever I am having in my stack, I am going to insert this element into stack. So the decision will be taken on the basis of state, input and stack. And what is the output? The output is that I am going to make certain changes into my stack with respect to state. So that is my transition function for PDA, which says that by taking certain state corresponding input and stack symbol, I am going to make changes into my state and my stack. So that is transition function. So I hope that you got what is actual definition of PDA. PDA consists 7 tuples, out of which 5 from finite automata straight away, and because I have added one memory, so I have incorporated 2 tuples into my finite automata, which are stack symbol and empty stack, and hence we are having 7 tuples in my PDA. There will be small change in transition function. Transition function now dependent upon 3 tuples, state, input and stack, and the output will be change in state and change in stack. So on the basis of this, we are going to pick that how our system will move forward. So that is overall introduction of PDA, push down automata. In next class, we will discuss that how to design PDA.